So we're going to take a look at a couple examples as how we use the charts, and we're going to take a look at how we do the mathematics for this. All right, so let's suppose that we want to find out the intensity of heavy traffic. So you go to the chart on page 503. Take a look at 503. You'll find that the value that they give, rounding off for heavy traffic is 80 decibels. So we want to find the intensity for that. We set that equal to 10 times the log of I over 1 times 10 to the negative 12 watts per square meter. So the first thing you do, you divide by 10, and this gives you 8 bells, is equal to the log of that unknown intensity over the known intensity for the threshold of sound, 1 times 10 to the negative 12 watts per square meters. Okay, then you take, I'm going to get rid of the log here, so you take 10 caret both sides, that cancels that out right there, and 10 to the 8th period, or 10 to the 8th exponent there is exactly that, 1 times 10 to the 8th, or you want to put it down as 10 million, you can, but I hate zeros, so I'll use this, is equal to I over 1 times 10 to the negative 12 watts per square meters. So we get I by itself, we multiply both sides by 1 times 10 to the negative 12 watts per square meters. So these cancel out here, and our intensity, done there. Our intensity is equal to then 1 times 10 to the negative 4 watts per square meter. Okay, so that's how we would handle going from decibels to actual intensity. So let's take a scenario now where we have 2 decibel levels, and we want to know how many times louder it is or quieter, depending upon what's being asked. So let's go to the next page and take a look at that. Let's suppose that we have a comparison. So the question is, how many times louder is a 93 decibel sound compared to a 31 decibel sound? So how many times louder is 93 decibels as opposed to 31 decibels? Well, the natural inclination here, of course, is to say, oh, well, 93 is 3 times bigger than 31, so it's 3 times louder, obviously. The problem with that is you're dealing with logarithms and not linear numbers. It is actually way, way more intense in the difference between 93 decibels and 31 decibels. If you take a look at the chart, you can see what I mean by that. You find something about 90 decibels and find something about 30 decibels, and imagine those 2 sounds, you know it's going to be more than 3 times louder. It's going to be a lot louder than that. So, as a comparison then, this is technically, when you compare things, you divide the 2 out. So this becomes 9.3 bells, and this becomes 3.1 bells. So this, you want to know how many times louder it is, so take 10 to the 9.3 and divide by 10 to the 3.1. Well, what do you do with the exponents of numbers that are dividing at the same base? Yeah, you subtract them. So that becomes 10 to the 6.2 power. So you plug that into your calculator, 10 caret 6.2, And it turns out that it's 1.58 times 10 to the 6th times louder. It's not 3 times louder, it's 1.5 million times louder. And that's the issue that some people have when they work in high intensity sound areas. You get close to an area where you can do some damage to your ears, so that's why you see people wearing those headphones. Many of them are sound reducing headphones where they counteract the loudness with a wavelength that will knock it down. Or just wear it and it keeps most of the sound out if it's really a tight fit over the ears. All right, the last one I want to talk about is suppose you have a couple of people in a room, and when they talk to each other, it creates a sound of 26 decibels. Okay, and they're so this at home. Let's say that this is their normal conversation level. Then they go to meet some friends at a little gathering in a room at a motel or hotel or something, some little gathering, and there's actually 36 more couples. And let's say they talk all approximately the same level. And so the question is, how many decibels is that gathering going to have? Okay, so what we're going to do here is we're going to figure out the sound intensity for 26 decibels. And this is going to equal 10 times the log of I over 1 times 10 to the negative 12 watts per square meters. Divide by 10, that becomes 2.6. And then take 10 carat of 2.6 and 10 carat of this conglomeration, which cancels out the log, which is why we did that. And it turns out that this is equal to 3.98. And that equals to I over 1 times 10 to the negative 12 watts per square meters. So I multiplied by this, and then you can see that's a very easy multiplication. 3.98 times 1 is 3.98. So that becomes 3.98 times 10 to the negative 12 watts per square meters. Now that's for one couple. But how many couples are in a room? Well, you have the one couple, then 36 couples or of friends or acquaintances get together, and they decide to all talk at the same time, which is generally how parties work. So we go ahead and multiply 37 times 3.98 times 10 to the negative 12 watts per square meters. All right, so when we do that, turns out this is 1.47 times 10 to the negative 9 watts per square meters. So you've got that much sound going on in your room. What is the decibel level going to rise to? So, then the decibels is 10 times the log of the intensity, which we just found is 1.47 times 10 to the negative 9th watts per square meters over the threshold of hearing, which is 1 times 10 to the negative 12 watts per square meters. And that value turns out to be 31.7 decibels. So, That means how much did the intensity level rise in the introduction of 36 extra couples to the one couple? Well, you just subtract 31.7 minus 26.0, and we got a decimal rise of 5.7 decibels, which isn't too bad, but it is noticeable. All right? So, for your homework or practice problems, we have 5 practice problems. This is at the end of the script that you're going to be given here. There are 5 problems pretty similar to what we were discussing. Have fun.